Hello students, this video lesson is about solving equations with several steps. The two main properties used to solve equations are the addition property of equality and the multiplication property of equality. The addition property of equality simply states if you add the same number to both sides of an equation, both sides of the equation will still be equal. And the multiplication property of equality states if you multiply the same number to both sides of the equation, both sides will still be equal. These properties are helpful in isolating a variable within an equation, which then determines the value the variable must be to make the equation true. This value is called the solution set, or the solution. So some simple equations that demonstrate these properties are x minus 4 equals 10 and 5x equals 35. My first equation, I'm going to utilize the addition property of equality by adding the opposite of the constant to both sides. 4 is my constant term, and it's being subtracted, so in order for it to go away or to equal 0, I'm going to have to add 4 to both sides. Negative 4 and positive 4 are opposites. When I add the opposite together, they equal 0. So on my left-hand side of my equation, I have just a simple x. And on my right-hand side, when I add 4 to the 10, I get 14. So I've isolated my variable, and I've solved the equation. I've determined the value x has to be to make that a true statement. On the right is an example of the multiplication property of equality. On this particular equation, I'm going to divide both sides by 5. Now, division is simply the same thing as multiplying by a fraction. So I divide by 5, or in essence, I'm multiplying both sides by 1/5. And when I do that, I get x equals 7, which is the solution to the equation. If I wanted to plug those values back in, I could verify that yes, this value makes both sides of the equations equal. Now, when you're solving equations, you want every single line to be right on top of each other, and you want the equal signs to be right underneath each other. Now, when you're solving more complicated equations, you have to do a little more work. Here's an example of a more complicated equation that requires more steps in order to be solved. So the first thing we're going to do is we're going to simplify both sides separately. So in essence, we're going to totally ignore the right-hand side and just look at the left-hand side. And we're going to simplify that side. And then we're going to ignore the right-hand side, ignore the left-hand side, and solve the right-hand side. How do you go about simplifying a side of an equation? Well, we're going to possibly have to distribute, and then we're going to add like terms. And after we've done that to both sides of the equation, we're then going to have to move all the variable terms to be on one side and all the constant terms or number terms to be on the other side. When we do that, sometimes we have a coefficient in front of the variable term that's not 1. If it's 1, x is basically by itself, because x equals a number that's really 1 times x. 1x or x, they really mean the same thing. But if I have a different number in front of the x, I'm going to have to use my multiplication property of equality and divide that away so that I can isolate the x. So let me go ahead and show you how this complicated equation would be solved. The first thing I'm going to do is I'm going to distribute the 7. I'm going to take that 7 and multiply it to both the 2, or the 7 times x, and the 7 times the negative 2, which is going to give me 7x minus 14. I did that on the left-hand side. And then on the right-hand side of the equation, I have to distribute the 2 to everything inside the parentheses. So I take the 2 times the 4x, which is equal to 8x, and the 2 times the 2, which is equal to 4. Now that I've distributed because you always do multiplication before you add or subtract, so we're basically following the order of operations on both sides. Now I'm going to add and subtract like terms. So I have to determine what are my like terms. If they have the same letter raised to the same power, that's a like term. So 5x and 7x are like terms, and they add to equal 12x. I'm adding the coefficients, the number in front of the x's. My constant terms are negative 14 and negative 6. I can change that to add the opposite, so really I'm adding negative 14 plus negative 6, and I get negative 20. On the right-hand side, my only like terms are the constants, 24 and 4. Those add together to get 28. If I want to rearrange my equation so that my constant terms are next to each other, I can do that. I'm using the commutative property. The order changes, but they're all being added, so that's acceptable. Okay, so now I've simplified both sides, but now I have to move my variable term to be on the same side as the other variable term. So I always like to move all my variables to the left and my constants to the right. It really doesn't matter. I like consistency. So that's my preference. So I subtract 8x from both sides of the equation. I'm utilizing the addition property of equality here. I'm moving the entire term by adding its opposite. The opposite of a positive term is going to be a negative term. So I'm adding negative 8x to both sides. On the right-hand side, I have opposites, so that simply goes away to 0. And I know if I add the 0 to 28, I get 28. So I don't even have to record the 0. On the left-hand side, I have 12x minus 8x, and I get 4x. I just bring down the other term on that side, which is a negative 20. So I moved my variable terms to the left-hand side. Now I want to move all of my constant terms to the right-hand side of the equation. So in order to move that negative 20, I'm going to have to add the opposite to both sides. So on the left-hand side, it goes away to 0. 0 plus 4x is still 4x. And on the right-hand side, I have 20, just the 28 comes down because the 8x is gone. Oh, I've added the 20, so I have 48. Now I have a coefficient in front of my x. In order to get rid of that coefficient, I have to divide it. If I do it to one side, I have to do it to the other side as well. So I'm dividing both sides by 4. 4 divided by 4 is 1, so I'm left with 1x on the left, and on the right, 48 divided by 4 is 12. I've isolated my variable, which in essence has solved the equation. I've determined the value x has to be to make that equation be true. With mathematics, it's all about practice. The more exposure that you have with the different types of equations, the more comfortable you are with completing them and solving them. So here's an example of another equation. 5x plus 3x minus 4 equals 6x plus 12 plus 2. Again, I'm going to just look at the left-hand side and simplify it. My 5x and 3x are like terms, they're variable terms. I'm going to add those together, and I'm going to get 8x. My constant, the negative 4, just comes down to follow. Now on my right-hand side, the only two like terms I have that I can simplify are the constants, the 12 and the 2. They add to get 14. Now that I've simplified both sides of the equation, my next step is to move the variable terms, ideally in my situation I prefer the left, and my constant terms to the right. So I subtract 6x from both sides, which gives me 2x minus 4 on the left and a 14 on the right. I've gotten rid of I've moved my variable terms. Now it's time to move my constant. So in order to move that -4, I have to add the opposite, which is a +4. So 14 plus 4 is going to give me 18. So now I have 2x equals 18. In order to get rid of my coefficient, the number in front of the variable, I have to divide it. But if I do it to one side of the equation, I have to do it to the other side as well. On the left, 2 divided by 2 is 1, so all I have is a 1x. On the right, I have 18 divided by 2, which gives me 9. My next equation has parentheses. So I can't necessarily add the items inside the parentheses like I would if it was order of operations and they were all constants. But I can distribute that -3. -3 times x gives me -3. -3 times a -7 gives me a +21. All the rules from Unit 1 come into play when you're adding or simplifying parts of your equation. So now I'm going to add my like terms. 4x minus 3x is going to give me 1x. And my 21, my constant, is just going to come down. So I don't have a variable term on the right. So I don't have to worry about trying to move my variable terms to the same side. I just have to move my constants to the right-hand side. So I'm going to subtract 21 from both sides. 10 plus a -21, I have more negatives, so I'm going to subtract because they're different signs. And 21 minus 10 is 11, but my answer is going to be negative because -21 is farther away from 0 than 10, and it had a negative sign with it. So my answer is x equals -11. My next example, I'm going to have to simplify both sides. My right-hand side can't simplify further. Those are not like terms. My 2x plus 7, they can't simplify further. But my left-hand side, 5 minus 3x plus 2, I can add the constants, the 5 and the 2. The operation sign in front of those terms go with them. I could rearrange that if I wanted to, so that my constant or that my two constants are right next to each other. I could say 5 plus 2. I use the community property and I changed the order. I've moved my -3x to be behind the +2. So mentally I can see that the 5 and 2 can be added together because they're both constants. And that's going to give me a 7 minus 3x equals 2x plus 7. Now my next focus is getting the variable terms on the same side. So I'm going to subtract 2x from both sides, which gives me 7 minus 5x equals 7. Now I need to move my constant terms, so I subtract 7 from both sides, which gives me -5x equals 0. Now, the object is to get the x all by itself to isolate the variable, so I have to divide away the coefficient, the number in front of the x, which is -5 in this case. A -5 divided by a -5 is a 1. Anything divided by itself is 1. So I just have 1x on the left. 0 divided by -5. It's okay to have the 0 above the line. When 0 is in the numerator, that just simply equals 0. So my answer to this equation is 0. The only value that will make this equation true is x, for x to be equal to 0. Okay, I would like for you to stop the video, complete these 3 questions, and then check your answers. So how did you do? We're going to have to distribute the 6 on the left, distribute the 3 on the right. Can't really add any like terms, so we're immediately going to go to moving our variable terms and then our constant term. And then we're going to divide away the coefficient, in this case is 3, and my end result is x equals negative 16. My center equation, the first thing I'm going to do is go straight to simplifying both sides of the equation. On my left, I have constants, so I can combine those. On the right, I have two variable terms I can combine. Now, since I only have one term that has a variable, I moved all my constants to the left. But then at the very end, I did a transitive property. 4 equals x, x equals 4. They're mirror images of each other. So I can always rewrite my equation and change the sides to be on the other side. My last equation, I distribute my 4 on the left, and then I can add like terms. On the right, I just had two constants, and I added those together. And then back on the left, I wanted to get all the constants to be on the right. So I had to subtract that 1. And then lastly, I had to divide away my coefficient. My final answer was x equals 4. Well, this concludes the lesson. And now I have 3 discussion board problems for you to complete. And then take a photo image and upload it to the appropriate discussion board. Be sure to show every line and line up your equal signs. They should always be right on top of each other. Every line should be equivalent to the line above, but your very last line should just have the x by itself, giving you the solution to the equation.